So, welcome to day 9 of our mechanical domain sessions. Today, we were going to start with the presentation part of your all the engineering, the mechanical engineering part. Today, we will be talking about all the concepts which you have gathered and how you will be presenting all that in form of a pitch, in a form of video, or in form of a documentation. All right. So before starting the presentation part itself, there were just a few parts left about mechanical design drawing part, which I would like to cover. So yeah, you guys have some idea about engineering drawing, right?
Yes, yes.
Um, can you guys recollect which projection we use in India? Like there is a first projection and there is a third projection. Do any one of you remember what that was and what we use in India especially?
I think we use the first projection, right?
Yeah, we use the first projection as well as I remember.
Yeah. Okay. And what is the difference between first and third projection?
Um, Correct me if I'm wrong, but isn't it like that quadrants, first,
Yeah.
first and third projection? It's similar to that. I don't know the exact definition, but it's similar to quadrants.
Okay. And what were the different orientations in which you used to present your like object or a part? Like what were the different orientations, different views of seeing a part on the drawing?
Front view, top view, side view.
Okay. And there was one more.
Isometric view.
Isometric view. Yeah. So I guess you guys have learned about how to use scale and paper and draw different views of a drawing, like even isometric view that was a bit different. So all those things which you learned in your engineering drawing classes, we are more or less going to be sticking with that. Okay? But there are more details, obviously. Um, so when we are drawing a part, an assembly, or a whole like robotic system, we usually divide our drawings into four parts. Okay? Whenever we are drawing a complete system of different parts, which contains different parts, obviously there will be like multiple parts which have their own individual drawing. There will be designs, layouts of each individual part. There will be an assembly drawing as well. So as you guys can see, there are four basic divisions. I will go through one by one. Assembly drawing, more like when you will assemble all the parts together, it will represent how are you assembling all those things. So it is more like what you will see in any, like whenever you buy a shoe rack or something like from hardware and you need to assemble that, you get an assembly manual, right? In that you probably see like set of instruction about how to assemble a single thing. A- Along with that, you also find some drawings as well. So that those drawings are more or less which we see in engineering drawing as well, like the assembly drawing. Okay. So what you will see in assembly drawing, um, an isometric view of complete assembly and one this and one exploded view of the whole assembly. Anyone knows what is exploded view?
Like parts like aligned but not like completely fit together, like just like if we remove the parts.
Okay, close, huh? So like yeah, like something like that. When you will like open up the whole design, but keep the same axis in which they were assembled in. So that is exploded view. So we make two types of designs in assembly view. Both are isometric. One is exploded and one is completely assembled. Part detailed drawing is something. Let me show you a better. Let me show you something. So this is a design of this a ring. Okay, this is what I found from Tata Motors. So this is a simple ring. As you guys can see in this one, this drawing, you can understand that this is a simple ring with a hinge which is coming out. Okay, but for that simple part as well, there is a complicated lot of drawing which you guys have to see. So this is what a detailed drawing is. I was talking about uh, part detailed drawing. This is that detailed drawing. Why is a part detailed drawing made? This is mostly made for the manufacturers or the fabricators who tends to make these parts out of like pure metal blocks. So we give every dimension, we give every tolerances, and like even the surface roughness and all material and all those parts. So let me show you this part. This is what this symbol is usually used for seeing about the surface smoothness. Yeah, so roughness, whatever you would like to say. For example, at the end here, you can see the surface roughness symbols. What are the symbol like, and what is the meaning of N9? What is the meaning of N7? What is the meaning of N3? So all of that is written in this drawing itself. So this is what a part detailed drawing looks like. Okay. More detail about this is key. You have to make sure uh, every designs this dimensions should be given in this, even in the cross section view, which you can see section B to B. B to B means this one. So even in the cross section, what is going on, even which screws, if there are screws inside it, which type of screws are being used. Here, for example, it is M4 screw written here. And how many? Two numbers. One is here, one is over here. So those things are also written in the detail view. Okay. Third is layout drawing. Layout drawing is what you usually use to make in your engineering drawing classes. What is this? The top, left, and front view, the isometric view, and in case of any detail design, you also scale up some part and show that in the drawing itself. So this is what you usually saw throughout your engineering drawing session, layout drawing. Okay. The fourth drawing is interface control drawings. So in the whole assembly, there are around 10, 15, 100, 200 different parts. If you are talking about a single part, then you will only talk about what is it directly assembling to. Whenever you talk about what is directly assembling to it, what part, like which feature of that part is allowing us to assemble these two parts, either screw holes or it is a lid design or something. That is told in the interference control drawing. Normally, what is shown in the interface control drawing is how it is getting attached with other parts. Okay. Um, so I gave a detailed drawing example. This is also present in your Notion. I will give it in the reference. Okay. Anything like that confused you in these four?
Uh, I could not understand what is interface control drawing.
Okay. For example, let me show you this. Remember this. I showed this to you in the CAD assembly part. So
I think I was not present in that meet.
okay,
Uh,
like there was a video which I showed you guys about the exploded view. Okay. So inside this, if you will be talking about, let's say, interference, a drawing of the base, lower base. Okay. So what all things I will show you to you guys, how it is getting attached to the ball bearing, this truss bearing, and how is it getting attached to the servo motor, because those two things are getting attached to it. Okay. So if I'm showing a isometric view of these two parts getting attached to the lower base, that will be the lower base, the like interference design of the lower base. Okay. For the upper base, I will attach it with the servo, with the normal bearings, the truss bearing, and the slit ring in between. Like together, this whole thing is actually the exploded view of interference drawing of the upper base, upper part of the base. So this can be an example, although this is not in the form of a drawing, but if you make a drawing for this, obviously that will be a interference drawing. Okay,
yes, okay.
Like, am I making it clear, or is it making it more confusing? Let me show you this.
I'm confused between assembly drawing and interface control drawing.
Interface. Usually, it would be better if I show this. Okay, for example, this. Um, okay, smart. Let me show you here only. Uh, you can see this block like box, right?
Yes,
This is showing the two parts which is getting assembled to it in the hashes. These two part is getting assembled, and how is it getting assembled? That is shown in this drawing. So this is an interface drawing.
okay. And
Oh,
how is it? Okay, so what is assembly drawing?
Assembly
Like,
drawing
it
will
is,
be like more like the complete system will be shown in that drawing. For example, let's just say ki you have nail cutter, right?
yes,
So how will if you will make an exploded view of the nail cutter, including its main body, the two or three types of blade inside it, the pins which is connecting it with the upper handle. If all
yes,
those things are shown in a single design, then it is a assembly drawing of the whole nail cutter. If
okay,
you are talking about the robotic arm, you will show all the linkages, all the joints, all the motors, and even the end effector. Everything included in that will be a system assembly drawing of the whole robotic arm.
okay,
And if you are talking about just the base, then interference drawing, which I showed you right now, this is the interference drawing of the base. But
okay. So interface
okay,
drawing is for parts only. Like if I
yeah,
choose a
like
particular
small,
part and we just
yeah.
explode it, it is kind of interface control drawing.
Whenever we are talking about interface control drawing, we will be saying ki interface control drawing of such part. For example,
Okay.
that was for upper base part.
Hmm.
Okay. And
Okay,
when
I
we are
got.
talking about assembly, we'll be
We'll
talking
talk
about the
about
complete
complete.
system.
Yes. Okay.
Okay. Anyone, anything else? Okay. Okay, I showed you the detailed drawing. Some parts of engineering drawing sheet which you guys have to make sure ki understand. This was not actually told exactly to you guys, I would say. So this is the title block. Normally, you guys used to write your name and roll number in this part, but what is this actually used in an industrial level drawing design? So what are the parts like in the title block? The logo of the company, the people who have worked on this, like who has made designed it, who has checked it, and who is working on the manufacturing, the design part number. For example, like I'm working recently on in Tata Motors in one of the grinding machine. The number of the grinding machine is M510077 or 0076 or 0477. These are numbers allocated to different machines. Even the parts, designated part, for example, this spindle part, front ring cover wala, has a part number 6011 51 0426. So that is especially written like here. What is the name of the part? Okay. What is it for? Like this is not actually important. This is just to complete the whole idea. The scale, the complete system where it is being used. For example, if you're making the base, you will write about key robotica, like rover manipulator here. Okay. You will be also talking about the projection, this part which you can see CAD A2, and then there's a diagram made. So we'll be talking about what this diagram mean, but we'll be this is for understanding which projection is being used in throughout this drawing, and also some part of like characteristics are also added here. For example, if you see any of the marks throughout the design, you can understand ki what that means. Like, for example, we add asterisks in our books normally. So, in the same way, if there are some symbols in the drawing, those will be like mentioned here. Okay. Other things are also added here. Like this is extended part of the title block where you'll be talking about the surface finish and like somewhat sometimes the tolerances which standard it is being used upon. For example, in ISO international standard, okay, these don't come like the part above this doesn't come under the title block. But yeah, you can add some things like some kind of notes. Generally, notes are added on the top left, but in this case, in the example which I showed you here, some things are told at the bottom right as well. Okay. So this is the scale and the material block which I said, the extended part of the title block. Here you will like this symbol is not to be used by us. This is more like planned out by the manufacturers. If we have an like in-house grinding machine, lathe machine, those will already have some specification key. What will be the tolerances? What will be the surface grinding like maximum smoothness which it can give? All those things are coming out from the machine which we are using. If we have an inbuilt machine, then it is something which we should take care of. Other thing which I asked with you guys only, ki what is the angle of projection and what is the projection plane? Okay, we'll come to the projection plane. Um, what is the angle of projection? So you guys told about the first angle projection and the third angle projection. You guys said ki it is somewhat like connected to the quadrants, as you can see in the uh, diagram itself. What are the quadrants we are talking about? And I told you guys ki we'll be talking about the symbol from what does those symbol mean. mean. For example, in here, this was CAD A2 के नीचे there was a symbol. So in generally, if like the person who is using the manual doesn't know about English by just some case, maybe I'm not sure, but yeah, this symbol is there to tell the person ki, is it a first projection or third projection view. So a first projection view is where like, for example, this is a first projection view. We have used the side view, then the top view, then side view, and then the front view. So in this diagram, you can see this is the first projection view, first angle projection, and that is symbolized by first having the front view, then the left hand view. In the third angle projection, you will have the left hand first and then the front view. So normally, like you have to make sure that you see this either this or somewhere it is written ki, is it in the first view or the third view. Another thing which have you guys anyone have tried drawing like normal drawing, sketch art?
Yes.
Um, have you heard about points of view,
Yeah.
viewpoints?
Yes. Perspective drawing, right?
Our perspective.
1 point perspective,
Yeah,
2 point perspective.
yeah. So the perspective drawing which we normally like, which we normally visualize from our eyes, right? If you are going to see a complete cube, you will mostly be seeing a perspective drawing, the perspective design. Okay. When do you guys see the orthophotic design? When you will be infinitely far from the object and all the light rays are parallel to each other, which is falling on your eyes. So normally, whatever like the way you see moon or sun or any star, if you have seen through telescope, those will look more orthographic than perspective to you guys. Ever try looking at your ball at a sponge ball or a like cricket ball in front of you, and then look at the moon. Both have spherical design, but you will see that in for the ball you can see around it a bit, but for the moon you can never see around the like rim of the moon. That is only possible for perspective drawing. Okay, like this is more talked about when you are talking about the isometric view. So isometric view is a part of the orthographic view, and you will be seeing like normally in fusion and anything you will be looking at the GUI, the graphic view system shows you the perspective view until unless you change it to orthographic. Okay. This is like normally not that much required, but sometimes even like uniform cube might not look like a cube. It might look deviated. For example, here also you can see this edge looks a bit of deviated angle. So in those cases, make sure to look after either you are looking at the orthographic or the perspective view of the body. Okay. Something about first angle view and third angle view. In the first angle view, if you guys remember from your engineering drawing classes, you should always align your front, right, and top views, right? You guys have heard about that.
Yes.
But if you are aligning and like, are you putting your front view on the top right or the bottom left? That is very much important when you are talking about the projection. Okay. Whenever you guys would have practiced making engineering drawing, it would have been emphasized to you guys to draw that front view at the top right. Okay. And for like Americans, most probably most of the videos which you will be seeing around, they would be using third angle projection. They will put the front view in the bottom left. So make sure if you are making the first angle projection, you follow this thing. This is one important way of understanding either you have used first angle projection or a third angle projection. If it is very much unbiased, then people look at the design, what is here. But understand this, you should never like break this rule. So, yep. We talked about the title block. We talked about the scale block. We talked about the projections. There's one more thing in the assembly drawing. You also add bill of materials. What is bill of materials? All the components which you have used throughout your whole design, even single screw, bolts, or major parts as well. All those are added in a single list. This is in Fusion 360 or even in SolidWorks. You usually get an automated bill of materials. Okay? But you have to make sure that if it is an assembly view, you add all this. This is used for understanding what all things you need to purchase for the equipment inside the design. Even for, let's say, you guys have already read throughout IRC and URC rule book, they say that the limited amount for all the components is 20 lakh or 25 lakh, depending upon which rule book you have seen. So those 20 lakhs and 25 lakhs will be seen, like how will that be judged? All the parts should be inside the system, inside the rover system. And how will you realize what all parts are there? All the parts which are in the item list, in the part bill of materials, are the part of your rover. Anything else, for example, wrench, screwdrivers, 3D printers, those won't be counted in that amount. And you can differentiate something that it is being used or not used inside the component is from this. So bill of materials is important not only while purchasing but also showing it, like while we say that a assembly a system costs this much. Okay, this is why bill of materials is important, and this is always attached to the assembly drawing. Section view. So there's one more part about your views, front view, side view, all those parts. Sometimes what happens, your part is like made in such a way that its left view, let's just say left view has been like covered by a sheet metal and no more details are being seen through like through that part. Okay. So to uncover those details, what we sometimes do is instead of putting in like top view or a left view or a front view, we add a sectional view to it and then define the section. Like for example, the section view is B to B section, and then this is defined on a different on like the other views. So for example, the top view for this has presented which section we are talking about, and the front view or the side view, like for this case both will be the same. So the front view or the side view is about of the section, and how we'll understand which part is cut and which part was hollow from the starting. The dashed part will be cut out and the hollow part will be not like, those will be like solid lines. They won't be dashed like this. So even in the screw part, you can see there's an axis, a dashed line, but there's no like dashes to fill the part. fill the whole part. So sectional view are sometimes used instead of using any of the front left or top view. You have to make sure sometimes you use this. And there are more details about engineering drawing. What you guys have to do is um, there is a video. Let me see. I have not attached it here somehow. Um, give me a minute. Okay. So this is a video. I'm attaching it here. In this video, there's like a lot of things which is told about how to draw your designs. Even what all these perpendicular part or like 0.01 is shown. How do you show like how many number of screw holes are there? Like you can see there are six number written here. So all those things are also attached in the video itself. How do you present tolerances? All those things. Do refer to this YouTube video to understand more about the drawing part. Okay, there are a lot of details. If I start telling about that, it will take its own 2 or 3 hours. If I'm not doing that. Instead, it's a 22-minute video. You can go through this and like refer to what is written there. We are keeping like we'll take into account all the things which are present in this video. Okay. So this is about drawings. How will you be able to draw in Fusion 360? It's simple. You go to the design tab, go to the drawing, and then draw from design to get like if you are talking about a single part, you will use from design. If you are talking about the exploded views, you can go from animation itself. For example, this is the animation part. If I go from here, I will get this as my drawing. Okay. So this is how you go for drawing in Fusion 360. It is not complicated. It is like really intuitive to understand. In case you don't understand this part, then watch some videos. There are a lot of videos about this. Yeah. Also, when you are talking about a CAD design, if you want to present it more in a more visual way, a better idea is to use an animation or the exploded view for your design or assembly. So you guys, if you guys remember, there was already a exploded design video which I showed to you guys. So from where did I get this? Again, I went to the design pop-up at the top left. There's an animation option. I went there. I got this screen. I got this view. If you want to change something, like there are a few things to remember about this. It is not very difficult. If you want to change the view, the way camera is changing, you can normally uh, shift your screen using the middle scroll button. Okay. When you will release it, it will automatically make a 1 second like this 1 second tab that you can increase or decrease to slow down or pace up your animation. And if you want to change the location of any part in the drawing, you can like just either explore it manually or like auto explode the whole thing all completely together or by only one layer. You will get all those options when you will click a right click on this parts. Okay. When you will manually explode it, you will uh, like you will get an option to move that part. When once you move that part, automatically there will be a this part generated. You can see the one with move icon. Such icons will be generated. Then you can like increase or decrease the time to finally like design ki how much time it will take to completely move from the initial position to the final position. So this is what animation is all about. That is not a very big thing. Okay. Coming to the presentation. Okay, before presentation, anyone have any doubt about drawings, animations, or exploded view? Anyone? If yes, go on. If no, then tell me no. No? Pakka?
No, no.
Yeah.
ठीक है, ठीक है. So in the next session, like the second half of this training session, we'll be talking about how will you present your design and what you will present your design. Like what is there to present. This is the most important topic for you guys. Throughout the mechanical session, you got to learn about different theories. You got to learn about some part of embedded system. You got to learn about the mainstream CAD. What is CAD? What is ANSYS? How do you simulate the strength? How do you choose your materials? What are the refined changes you need to do? What are the refined components you need to add in your assembly? So all the parts which a mechanical engineer tends to know for at least designing. I'm not talking about maintenance or something, but yeah, for designing at least a prototype, everything, every part was told to you guys from day one to day eight. Now it's time for you guys to present the upcoming task. All right. I want you guys to understand that right now we have 14 mentees under us. There are two topics. We'll go further into this. There are two topics which we will be talking about, and there will be a division into two teams. The presentation part will be a collaborative work. You will be working with other six team members to present your whole assignment, and where the presentation will go. What is the actual value of the presentation? We are not just giving you a task. This is actually going to the places where it needs to go. Okay? This is a serious assignment. You can't change the deadline. You can't change the whole idea. All right. So whatever I'm going to tell you guys from this moment onwards are to be kept with, like, you should keep your attention. All the things are going to be more serious. All right. So inside presentation, what is the goal of our presentation? So we will be giving you tasks. There are two tasks, and you have to explain what you did throughout the process of designing those tasks in a 1 to 3 minute video format. Okay, you have to present your team. You have to present your work. What are required for your video submission are the visual introduction of your team members, your name, and your face is required. What are you going? What all things you will be talking about in the video? You will be talking about your problem statement which you got and what you have worked upon it. Mandatory things which is required to be there in the video are the CAD model, individual parts, the assembly of the whole design, exploded view, animation, and the engineering drawings. All the things which were covered from day 5 to today, day 9. Okay? Even the simulation of the part is also required. I have not added it here, my bad, but you also need to show what was the simulation result of your part. Okay? Then you will be explaining about the theories behind the engineering design which you did, whatever relevant topics which you found out throughout it. Because the you'll see in your problem statement, there are two problem statements, both need their own engineering ideas. Okay? So there will be something to talk about, and you will be talking about the theories and two engineering innovative points which you added from your own mind or worked upon from some initial idea. Okay? Minimum two, you can add more, but don't go above three or four. Four, let's just say four. Okay? We have to keep the video length in between 1 to 3 minutes. Okay? Your video, like your team members' name should be there, who all have worked upon it. Their videos should be there. After that, you can keep all the video on the screen, like whatever you did, or maybe you can add upon some more parts from like real, like camera shooting and all those stuff. This is not more like aesthetics. It's more about your engineering capabilities. But yes, keep minimum amount of presentable way for it. Okay. What are the problem statements? So problem statement number one, design an end effector that is capable of completing the following tasks. There are 5 tasks. Okay. All of these are what is relevant for our URC and IRC 2024 URC is and sorry 2025 URC and IRC. So what are those parts? It can manipulate switches, keyboards, door handles, push buttons, and plug in and plug out USB. You won't be going into the electrical details, software details, but you will make a mechanical design which will be capable enough and like delicate enough, and all the constraint sizes should be kept in mind given that these are the problem statements. Okay? This is one problem statement. We have talked about this in one of the sessions with some of the mentees in when we were talking about the overall problem statement of summer project. So you will find a Notion page where we have talked about this. You'll find some references which we got from there. And from there on, you will be working on this to complete the whole design. Okay. Problem statement number two. So Team Roboticus, our team name, is also working upon another project for which we are soon going to get funded. This was our first project to work upon, and the project was the robotic dog which we are building. One of the problem statements under that robotic dog which we are working upon is the robotic dog should work in the indoors human plant surfaces. And one big thing which we found out is that the normal robotic dog doesn't work, like normally skids on the tiles and all different surfaces. So we are working upon that problem statement. And in that big problem statement, there's a small part. What is the small part? Is to design the feet of the robotic dog, which is another project from Team Roboticus, which should complete the following tasks. Number one,
Pranav,
yeah.
uh,
Uh, let, I guess let me finish. Just give me 1 minute. Okay. So adapt the with the floor design, and even if there is some uneven floor, it should adapt with it. If the robot is not working, like has reached to an edge, it should also grip to it. Those things are being designed right now. Even Soumyadi would be leading you guys with this after the meet on some any day. Like we will be talking about that in the meeting. But yeah, so it should adapt with the floor design. It should be made keeping in mind that it is going to be used on human-made surfaces, and mostly it will be using passive mechanics, or if you are using some batteries and actuators, it should use least amount of energy. These are the two problem statements where, so before going ahead, just a bit of idea about what we have worked upon till now. This is already, you guys would have seen this in Fusion. So we had worked upon ProPup version 01, and this is designed right now. As you can see, the end of the legs are not completed yet. We were first initially planning to put some rubber enders, but now things have changed. We have started with a problem statement. So we'll be talking about that. Okay. Yeah,
अच्छा,
Sanjay, go
let's
on.
just ask the people
So,
की
Soumya ji, yeah.
हाँ
आप बोलो
हाँ
बोलो.
I was telling you, let's just ask the people who are attending ki what can be the problem by using this kind of design.
Okay. आप ही लीड लो, बोलो.
मैं वही बोल रहा हूँ कि लोगों को पूछते हैं ना कि हेलो जूनियर, what can be the problems related to the design of a end of a lens which is rounded uh, at the tip.
Okay. Anyone who wants to answer this? What were the normal problems which you face? Yeah, Pratik, go on.
One thing would be the friction, of course, because a rounded object will have less contact surface area. So that would be an obvious issue. Second being that if you go onto a sharp surface or something like that, I feel like the risk of it being chipped off on a hard, blunt surface is more for that circular object compared to something more like a paw of an astronaut.
Yeah. Anyone else? ये अच्छा point था. The second point was very good. Anyone else who wants to add?
Oh, well, I saw a hexapod video. So I like in the video I saw that it's actually hard for like robots to like stand on their own. Like we have to make some rubber surface or like in that video that guy made some silicon like silicon foot like structure for the hexapod to be stable.
Hmm. Hmm.
Okay, let's consider your
Normally,
point. We are adding a rubber tip on the circular end. Okay, we are covering the whole circular end with rubber. So now what can be the problem that may come in our design for the dog to like stand up or maybe any kind of problem with the dog um, while it's moving terrain or
One point can be that due to the shape, the surface area of contact is very less. So if the uh, bot is operating in regions with uh, sandy terrain or something like that, its legs can sink into that.
nice. Anything else?
Could you repeat the question? For some reason, it got cut off.
Okay, so the question is, you can see the leg here, right? So someone among the audience told that uh, this will be skidding on plane surfaces. So another one just countered him with a reply that we can cover the tip, the circular tip or maybe spherical tip with rubber. So now what can be the other problems by using this tip circular, sorry, spherical tip structure or maybe the rubber tip, anything.
Uh, One more thing, Dharmi, if this hasn't already been stated before. Um, since it's one point of contact, right? I feel like the abrasion on the surface will be a lot more since it's also a spherical surface. So it'll get worn out quick and again, so grip drops.
So what basically you are telling is the spherical base will be gradually uh, like weared off and it will be more kind of a flat base kind of thing, right?
No, no, no. I'm talking about the rubber contacts. If you take the surface for a grippier surface, if in case the entire thing is designed to be grippy like that, then your point stands.
Okay. So just like a tire of a cycle, when it gets flattened, it takes up too much of area and yeah, too much of friction. Right.
Yeah.
Anyone else wants to add anything? Or maybe any kind of solution to meet this kind of problem?
Is this one possibility that if it's on a slanting surface, then like instead of the points which are in contact with the ground being like below the robot, like it will be on one of the sides. So it won't exactly be able to move up. It would take a lot of energy or something. Like it has a high chance of slipping.
Mhm. Okay. Any solution? Anyone? ठीक है. I don't think anyone is uh, innovative enough right now. So, Pranav, we can just talk upon this design. Maybe if we are uh, really near to that slide where this is problem, the solution, maybe one of the solution of the problem is described, or you can just go on and just let me know when that slide comes up.
Uh, like we can right now listen. Like what was one idea? Like let me just give a brief about it. So like we were having one possible idea which we were talking about was using pins which somewhat mimic the design of a claw, not just at the forward part, but at the whole palm, which, when pressed along an uneven surface, would take the shape of the surface at the same time give us more contact points. Okay. And how are we going to use those like different pins? How are we going to lock them passively or like unlock them when the feet is again like up for the next walk cycle? So सौम्यदीप कुछ ऐड करना है या फिर आई गेस वी आर टॉकिंग अबाउट दिस राइट.
हाँ, obviously इसके बारे में बात करना था. So the thing is, I want you guys to interact with me a little. Um, सब लोग तो म्यूजियम गए ही होंगे, साइंस म्यूजियम्स.
Yeah.
हेलो. हाँ,
हाँ.
तो साइंस म्यूजियम में एक चीज होता है ना कि डिफरेंट काइंड ऑफ लाइक एरे ऑफ पेन्स, जहाँ पे तुम कुछ भी चीज रख दो, दे विल टेक द शेप ऑफ योर ऑब्जेक्ट.
यस यस.
सभी को समझ आ रहा है मैं किस बारे में बात करना चाहता हूँ? मतलब बहुत रील्स में भी आता है, एंड साइंस म्यूजियम में ऑब्वियसली ये चीज रहता है कि डिफरेंट डेंसिटीज ऑफ पिंस और मे बी सिलिंड्रिकल रॉड्स, एरे ऑफ सिलिंड्रिकल रॉड्स. ठीक है, तो वो ऐसे रहता है, एंड यू जस्ट पुश योर हैंड अप ऑन द नीडल्स, एंड वो तुम्हारे हैंड का जो भी इंप्रेशन है, उस इंप्रेशन को मिमिक करके ऊपर जाता है सारे पिंस, या फिर जो भी हो सिलिंड्रिकल छोटे छोटे रॉड, एंड डिफरेंट डेंसिटीज के होते हैं. वो ये भी दिखाता है कि कम डेंसिटी है तो अपना जो भी हाथ का जो आउटलाइन है, वो आउटलाइन काफी रफ आएगा, मतलब अच्छे से नहीं आएगा. एंड हाई डेंसिटी वाला भारी भी होता है, एंड दे टेक अप द फुल लाइक हैंड शेप. जो लोग म्यूजियम गए हो, म्यूजियम में ये चीज दिखा जिन लोगों को भी, वो बताओ एटलीस्ट.
Yeah.
मैंने ऑनलाइन देखा है.
हाँ, ऑनलाइन में रील्स वगैरह में देखा है ना.
हाँ हाँ.
हम्म. तो I want you guys to be a bit uh, thoughtful about this. मतलब इस बारे में थोड़ा इनोवेशन डालना है हमें ऑन द फीट. क्या हम इसको अपने फीट में रख सकते हैं? मतलब पैर के नीचे, अपने रोबोट के पैर के नीचे, ऑब्वियसली नॉट अपने पैर के नीचे. हाँ, रख सकते हैं.
रख सकते हैं, बट उससे वो मिलेगा क्या? मतलब उससे प्रॉब्लम कैसे
क्या
सॉल्व
मिलेगा?
होगी? मैं पूछ रहा हूँ उससे हमारी
Like,
प्रॉब्लम कैसे सॉल्व होगी उस पिन्स को नीचे रखने से?
okay. तो थिंक ऑफ दिस लाइक दैट कि हमारे जो भी पिन्स है, पिन्स के नीचे रबर सरफेस है. ठीक है, मतलब रबर कोटिंग है. ठीक है, नीचे. तो मोर नंबर ऑफ पिन्स, मोर एरिया, एंड मतलब मोर कॉन्टेक्ट है तो मोर फ्रिक्शन. डन. अपना फर्स्ट
यस
प्रॉब्लम सॉल्व, सी इंटरव्यू वाला.
यस यस.
नेक्स्ट, रफ टेरेन में अगर हम जाएंगे तो हमारा जो भी स्पेरिकल वाला जो पैड है, देयर इज अ चांस ऑफ टिपिंग दैट ऑफ, जो कि एक बंदे ने बोला है.
हम्म.
तो हम अगर ऐसे रखेंगे, मतलब हम जो भी डिजाइन अभी प्रपोज कर रहे हैं, वो हम अगर रखेंगे, so that will take the shape of any of the terrain that is available, because that is basically a shape mimicking device, right?
यस यस.
तो वो शेप जब ले रहा है, तब क्या हो रहा है, हर एक पिन का हाइट एक एक अलग अलग है, एंड और हर एक पिन के नीचे रबर कोटिंग है. तो दे आर द रबर इज हेल्पिंग to make the friction, and ye pins will take up the shape so that we can maximize the friction in case मतलब कोई भी रफ टेरेन हो तो लूज रॉक्स या फिर लूज ऑब्जेक्ट्स अगर स्लिप ऑफ अगर होगा कोई भी लूज ऑब्जेक्ट, तो मतलब पैर स्लिप ना हो जाए. पैड इमीडिएटली उस मूविंग ऑब्जेक्ट या फिर कोई भी मतलब रोलिंग ऑब्जेक्ट का शेप ले लेगा, एंड इट विल हेल्ड अप. अंडरस्टैंड?
Yes.
बाकी सब हाँ दिक्कत
Acha, why do we need like pin design if we keep a very soft surface also, which can like मतलब उसके ऊपर थोड़ा pressure दूंगा तो it will take the like the floor design also.
ओके
Okay,
हाँ
I
So
would
like a
दैट्स
like
एन
bit
to say
इंटरेस्टिंग
softer.
क्वेश्चन
Samir. हाँ आप बोलो आप बोलो.
नहीं नहीं तुझे अगर बोलना है तो बोल सकते
Okay. Okay. About the normal spherical design with like let's say कि less strength so that it can take shape of the surrounding design. Um, First thing, if you are using such like such material which is very loose, like which is very much like take the surface design, what will happen after few cycles of walking? It will tear off. Okay, if there will be any sharp edges or like the it is if it goes through a sharp object set of sharp objects, Lego, वगैरह, all those things, then it may
जस्ट
cut off. First
स्मॉल
thing.
एडिशन स्मॉल एडिशन स्मॉल एडिशन छोटा सा
Okay.
किसी ने भी
हाँ,
F1 देखा है
Yeah.
F1 कार्स जब स्टार्ट होता है तब उसके टायर्स के टॉर्सन देखा है कभी किसी ने अगर
Tires
देखा
का
ना हो तो
what?
प्रणव
Yeah.
ट्रैक
द
रेसिंग का
टॉर्सन ऑफ
वाला
द
ना.
टायर्स हाँ अगर कोई भी वीडियो है तो दिखा दे जल्दी से
Yeah, yeah.
Tire warmers?
Yeah, this one only.
एग्जैक्ट दैट
Uh,
एग्जैक्ट फोटो
yeah.
हाँ दैट एग्जैक्ट फोटो अगर सॉफ्ट रखेंगे तो दिस विल हैपन जो प्रणव ने बोला कि देयर इज अ चांस दैट इट विल टियर ऑफ दिस विल हैपन मतलब बहुत ज्यादा भी नहीं लग रहा पर अगर हमारा रोबोट का जो स्पीड है वो स्पीड काफी ज्यादा मतलब थोड़ा ज्यादा भी हो एंड वी आर ट्राइंग टू कीप दिस विद इन द बजट तो ये प्रॉब्लम हो सकता है प्रणव कंटिन्यू
Other thing which I wanted to add was कि we are also talking about edges. And when we are talking about human surface, like surfaces made by human, a big question mark for robotic mobile robots is will it walk through the edge of like uh, stairs or table or something like that. So what will happen? Like what we are also considering is such sharp edges of some table end or the stairs, which although like rubber spherical like ends may take a some part like some shape of it, but it is better to use pin design so that in case it slips like it tries to let's say कि come down of the stairs or come up on the stairs, it can take some stability from the side of the stair as well, not only from the top of the stairs. So it basically hinges with the side of the stair if you're talking about the edges and then pulls itself back up. So we were thinking about that as well. I guess Udipto, like, is there any counter question
No, no,
or
it's
Sujal? Yeah.
Then we'll need to change the shape of change the orientation of pin back to the normal after each step.
Yep.
So we'll need a lots of
That.
actuator and also uh, we'll have to make some adjustment key if different forces act the amount of compression that each pin will undergo will be different.
Yeah.
Okay.
To.
No,
That's
we
Yeah.
don't really need
yeah.
to have an actuator for every pin. Like what
Hmm.
I was thinking
Yeah,
how it
answer.
would work
Yes.
is like if we could just leave some space and attach springs to the pins, it will come back to its original position. Like what I was thinking is. So that's what I was going to ask is it will require extra space because I was thinking it would work like that rather than having actuators.
Nice observation, and I would support this kind of invention actually. Both अच्छा. Anyone else wants to add up a cross question? Okay, Pranav, take over.
Yeah, sure. So yeah, you guys had a good discussion about this. We will be talking about this more detail. Okay, oh, not only this but also the end effector. There will be like when we will be closing down with our mechanical training sessions, then we are going to start with it. And about the timeline, okay. So yeah, you discussed about rope up. So what is the goal of the presentation and the timeline? So recently we are going to have some pitch inside the campus as well as outside the campus for the sponsorship of both the projects. And we need you guys to make such video which we can present in front of those pitches, those investors, so to show that we are having a lot more things rather than just making our own projects. Okay. So those videos should be professional. Those videos should have a lot of technical details told, which shows that you have gained a lot of knowledge out of such training sessions. Okay. We want you guys to pitch this. Not only that, these videos, the both the videos would be put up on our YouTube channel publicly as the first videos in our channel. Okay. So if we are growing up as a whole committee, a whole community of students from different domains together, you would be proud to have the first video of your own, right? So this will be the first public video which will be going up in the YouTube channel from Team Roboticus. All right.
Um, Pranav, I just
Yeah.
wanted to. I know it's a bit like out off topic, but
Yeah.
for the sponsorships, I just saw that ANSYS was giving free ANSYS Pro softwares for all student design teams. So I think
Um.
can get ANSYS.
Okay. Sponsorship. Uh, who is giving to us? First, we are talking inside the campus. We are going to finalize our faculty advisors. One is already known to a few of you guys. Sir Vikrant Rachela, chairman of Railway Research. Another sponsorship, we'll be talking about external sponsorship. It is not about software or a hardware like a given team. It is more like money oriented. Okay. Financially, they
Okay.
will help us. And we'll be talking about like off the like meet right now. Okay. If you have some input now, like you guys, when we will be starting with the meets of is the projects or these two problem statements and the project itself, there is one team which we have created under the management team and taking a lot of input from the people in the community. So we will take up your points in there. Okay.
Sorry for
Right.
interrupting again.
Yeah, not an issue. So yeah, where were we? So these are the videos. This is where your videos will be going. And to let us to let everyone know what is the value of the videos which you will be making. Here it is. What is the timeline? The last thing. This is a 100-hour challenge. Okay. 100 hour is 96 plus 4 hours. 96 is 4 days plus extra 4 hours. And to give a more boost to you guys, we'll be starting it from 16th June 2025. evening 8 p.m. onwards. All right. So 16th June is Monday, Monday evening. Till then, like tomorrow will be the last class for the mechanical. Tomorrow is 13th. You will have 14th and 15th to discuss about the ender effector and as well as the feed design, the overview of the ProPub. Okay. All the all these meets about introduction of these projects should be from your side. You should ask us that yes, you guys want to meet us. Then we will keep all these meets. We will have some formal meet from our side as well, but we don't expect that you guys will get 100% idea of what is happening inside in these both of these projects. Okay. So we are expecting now a lot from your side to start indulge in those projects, indulge in the meetings. There's a Discord channel made for the same reason. And if you guys would have noticed, we sometimes stay in the Discord channel till 3 a.m. at night, as well as morning like 10 to 2 p.m. sometime. Okay. So if you guys catch us up there, plus point brownie points to you guys. Okay. That would be great thing. But yeah, this is the projects. And last thing which is left out is team distribution. Soumyadeep, hey
Yes.
Tantresh, uh, let Tantresh handle this. Tantresh, are you active? Acha, Tantresh is not here. Hitesh आ गया. Okay. So, हाँ ये Hitesh, are you active? Yep. Can you just put down a poll between the two different projects which we are giving to the like mentees in the training group? Okay. So there will be a poll for you guys. Right now, put your first plan. Okay. We'll be distributing this in 7 plus 7, or like in case like there are less people included in this, then we'll be evenly distributing people in both the problem statements. Pick from your side in case there are less people in one and more in other problem statement. Try to negotiate between yourself. You can change your problem statement till 16th 8 p.m. Yes, Swamiji.
I want maximum. Okay. Um, I want maximum innovation from this two projects. So discuss among yourselves and find the best thing you get out of it. Because actually, this will be a really fun thing to do if you innovate something which no one has yet. All the best, guys.
Are you guys excited for both the problem statement?
Yeah.
Yes, definitely.
Yes.
Okay. I guess only who were the two people who initially came to my room on like what was that
Me
event
and
also
Siddhant. Me and
on
Siddhant.
farewell? Okay,
It
you
was
and Siddhant.
Sid-
Okay, so Pratik, you have seen the uh our first design. By the way, let me try to show you guys the like everyone the video of whatever has happened in Pro. Just 1 second. Give me a second. Okay, let me try to expand. The last time, this is a video when our battery was like completely gone. But yeah, okay. So this was the first prototype which we showed in our hardware modeling competition. We are we have yet to change the main body. We are not able to complete that printing due to which it is like this right now. But yeah, we are working upon it, and we would rather like you guys to join us in. Is this as good as the Mars project, or is it slightly better? I'll not give you an option of lower one.
As good as.
Okay. Others, you can say as good as if you find it key. It is not that good. Let's keep the respect of the first project.
Yeah, it's as good as.
Okay. Do you guys? Does anyone know ki which all other universities are working on robotic dog right now? Anyone knows about it?
Like almost every tech university tries for like robotic dog kind of project.
Every university, you're saying?
Like not every, but like like all the major like whatever, like even the locally famous colleges like try for it. Like it's very popular project.
Mm, okay. Well, the only one which I know is has been working upon for at least 5 years is MIT. Massachusetts has only one project, a university based project, not about industry based. A university based project on RoboDog is being built by MIT. There are a few other universities which we got to know, but there was not any formal team created for that, and there was no any like clear documentation about it. Even we got to hear that IT Kanpur is working on their robotic dog, but we have not found any pictures of it yet. So we're not sure. But yeah, you guys can go see what Cheetah and Mini Cheetah, these are two projects from MIT, are actually doing right now.
Oh, yeah, it's the
And
fastest robotic dogs right now, right?
yeah, yeah. Okay, by the way, the poll is up, guys. You guys can go right now and put up your polls, put up your votes in that. There are 6 people right now for the feet design, 3 people for the end effector. I would like you guys to also announce it in your informal group right now that what is this all about. And there's time till there's time till 16th. Okay. So you guys can work upon this. That's it, guys. That is from our side. I hope that this would have brought some dopamine into you guys. Hopefully, the pressure is not that much. And from the giver side, I don't really know how much it is being felt right now. I hope the excitement overcomes that pressure, and hopefully, we are giving you guys good enough problem statements to work upon. So, yeah. Um, Anyone, any doubts? Anything to ask upon, ponder upon? Anything you want to discuss with Aswamedi? We are going to have another meet in detail, but yeah, right now in general.
Have you guys decided, like, are you sure, like, have you completely designed the robotic feet? Because I am actually curious whether you guys
See,
are gonna
robotic,
use the,
right now it is in a conceptual point.
but you guys have decided that you are gonna use pins.
Matlab, that is one of the like planning after 3 or 4 meets. Swamidip, am I right about number of meets?
No, because I'm actually
Swamidip?
curious, like, how are you gonna implement that pin system? Like, are you gonna leave space and use springs like I was saying, or are you gonna use actuators, like you're saying,
Well,
or if anything
it would
else?
be much better. It would be much better if we could passively design the thing without any energy requirements. But at the same time, we had thought about like even in this on this evening itself, I was talking with Soumyadeep about how can we implement this idea. That only took me time that I had to extend, like I had to delay this meet. So we were talking about something which was like you were talking about how it will come back or how it will be stuck at a position. So we're talking about zip ties, taking some inspiration from the zip ties. We're talking about the pin mechanism. Then out of a sudden this claw system also came. So
Mm.
right now it can be changed. If there's a very good idea, yes, we can change. There will be a healthy discussion about it. But
Yeah, you can
uh,
also take inspiration. Like after what I thought, I just went online and checked. So the first thing that I saw is like how a normal lock and key works. So when a key is inserted, all the pins that are inside the lock they go up. So I was thinking something similar.
yeah, there are pins behind them. There are springs, right? You're talking about
Mhm.
that.
Yes, exactly that.
Okay, we can talk about it. Yeah, there is a possibility of new direction. Like even who told about the spring idea? I'm not sure.
Yeah, I only did that.
Okay,
This one, right? The spring with pins.
yeah, to bring back
Yeah.
the
Mhm.
pins. Like, that was also a
Yes.
cool idea. Like we hadn't thought about that then, but abhi that was a new idea which we got. Any
Yeah,
doubts on
because if you
design? Try
use
reducing the sun
actuators, you
spot.
have to use it for every single pin. No, that is not practical, I think.
Yep, yep, yep. See, matlab, there are a lot of like when we think about some design, some prototype or some innovation now, there are a lot of yeses, but then a single no destroys the whole plan.
Hmm.
So there are things to think, reject, ponder upon, like go into some research paper if we don't find some initial flaws with it.
Hmm.
So yeah, there are things to think about. And it is actually a very thoughtful and very interesting problem statement. None of the even the industrial robotics haven't thought about adding claws to increase the grip. It is something new.
For that pins idea, just a small
Okay.
shot into that, we could probably create a magnet that faces like one side of the thing will be slightly magnetic, and the other side will be plastic or something, and then we can create a, electromagnet within the bot that just powers on. It doesn't have to be very strong since the lateral displacement is very little. And then we can mold that electromagnet to a certain shape and switch it on whenever it gets, so that we don't use much energy as well, since we don't need to make a very strong electromagnet. At the same time, we can mold it to any shape for the initial shape. For example, if you wanted like a real dog's paw, it can be in that shape.
Talking about that, I remembered something about eddy's current. In electromagnetic system, it doesn't allow any this ferromagnetic materials. Sorry, yeah. So it doesn't allow ferromagnetic materials to either change its motion. If it is moving, it is moving. If it is in rest, it won't allow it to move. That causes because of some eddy current and stuff, which somewhat corresponds to your idea, if I'm not wrong.
I mean, I think your idea is better, but like is not what I'm trying to reach. I'm not sure if there's some communication gap in between, but it was more like just a switch on, switch off type of situation. That let's say if you feel like that at one point you have traversed a surface, like for example, I'll give a real life example. Like a dog goes into water, it's like a muddy surface, the pins mold to that shape of the surface, and then the moment it goes outside the water, the dog takes a small break, like, and then that electromagnet polarizes and for a small brief moment depolarizes and then reaches back to the original shape that allows it to walk on normal surfaces.
Yeah. Okay, that was a lot to think about actually. Okay, Pratik, just I guess who is the meeting coordinator? Rupesh, I guess.
No, it's me, Ayush.
Okay, Ayush. Okay. Just keep this last point in the MOM. Okay. Pratik will be talking about this. Basically, right now I have another meet with my team. So, okay. We'll talk about this. Okay. If anyone have any other suggestions, put that in your unofficial group. From there, put it on your MOM. Okay. We'll be talking about this. All right. For now,